In a stunning turn of events, the James Webb Telescope has just made an astonishing discovery that has left the scientific community in awe. The telescope has managed to capture not one, but multiple exoplanet atmospheres, all in one single image. And what's even more mind-blowing is that these exoplanets are located in the habitable zone of their star, raising exciting possibilities about the potential for life beyond our planet. The habitable zone, also known as the Goldilocks zone, is the perfect spot around a star where conditions are just right for liquid water to exist on a planet's surface. If you're eager to find out more about this incredible discovery, then make sure to watch the video till the end. We'll explain everything about this amazing discovery. So, let's start. It was in the year 2022 when the James Webb Telescope captured the light from WASP-39b, WASP-39c, and WASP-39d, three exoplanets revolving around a star located 700 light-years away from Earth. These exoplanets are slightly larger than Earth, with WASP-39b being 1.1 times the size of our planet, WASP-39c having 1.3 times the size, and WASP-39d being 1.4 times larger than Earth. The discovery of these exoplanets was first made by the WASP, with a wide-angle search for planets using the transit method. This method involves looking for the slight dimming of stars as a planet passes in front of it. However, the exact size of these planets could not be determined using this method. But the James Webb Telescope solved this problem by capturing their atmospheres. WASP-39b, WASP-39c, and WASP-39d are hot gas giants orbiting very close to their parent star. All the three exoplanets were previously known, but the James Webb Telescope provided a never-before-seen glimpse into their atmospheres. It managed to capture the light from these exoplanets after they passed in front of their star, giving scientists a chance to analyze the chemical properties of these faraway worlds. Marine scientists have discovered that WASP-39b has an atmosphere of hydrogen sulfide, indicating the presence of clouds in its sky. On the other hand, WASP-39d has an atmosphere of sodium, indicating clear skies. As for WASP-39c, it has an atmosphere of both hydrogen sulfide and sodium. The difference in their atmospheric composition suggests that these planets may have different weather patterns and climates, despite being so close to each other. If you're wondering how the James Webb Telescope was able to capture the atmosphere of these planets, here's a detailed explanation. When a planet passes in front of its star, the starlight filters through the planet's atmosphere before reaching our telescope. By analyzing the light that passes through the atmosphere, we can determine the types of waves that get absorbed and the specific elements that cause the absorption. Each element has a unique atomic structure, and when it absorbs energy, it only does so at specific wavelengths. So by observing which wavelengths get blocked, we can figure out what elements are present in the atmosphere. This process is called spectroscopy. The James Webb Telescope uses a device called the Near-Infrared Spectrograph, or NIRCam, to carry out this process. It works by splitting light into different wavelengths and taking a spectrum of the starlight. By analyzing the spectrum, researchers can identify the elements that absorb the light and hence determine the composition of the atmosphere. For instance, hydrogen sulfide absorbs red and blue light, while sodium only absorbs red light. This helps us to distinguish between the two and understand the different atmospheric conditions on these planets. But the James Webb Telescope did not stop there. It also provided valuable insights into the weather conditions on these exoplanets. The telescope captured a drop in brightness on WASP-39b, which indicates the presence of clouds in its atmosphere. Clouds reflect and scatter light, which can cause the planet to appear brighter. However, in the case of WASP-39b, the planet dimmed, suggesting that clouds were present in the part of the planet facing the star. Additionally, WASP-39b also exhibited signs of a powerful wind blowing in its atmosphere at a speed of about 9 kilometers per second. This discovery was made possible by observing the change in the planet's brightness over time. When a planet rotates, different parts of its atmosphere move in and out of the line of sight, causing variations in brightness. By analyzing these changes, scientists were able to estimate the planet's rotation period and calculate the wind speed. These findings suggest that the weather on these exoplanets is quite dynamic and warrants further investigation. What's even more remarkable is that all three exoplanets, WASP-39b, WASP-39c, and WASP-39d, are located in the habitable zone of their star. This means that they could potentially support life as we know it. The discovery of these exoplanets and their atmospheres has raised many questions about the possibility of life elsewhere in the universe. While the presence of clouds and winds does not directly indicate the presence of life, it is an important clue for astronomers trying to understand the conditions on these planets. Liquid water is considered to be an essential ingredient for life as we know it, and the presence of clouds and winds could help regulate the planet's temperature and create conditions suitable for liquid water to exist. As we continue to explore space and learn more about the planets beyond our own, we may one day discover evidence of life on other worlds. What's truly amazing about the James Webb Telescope is its ability to observe things that have never been seen before. It is a technological marvel that has allowed us to peer into the depths of space like never before. One such discovery was the observation of the atmosphere of WASP-39b. WASP-39b is a gas giant located 700 light-years away from Earth. Its discovery was first made in 2006 using the transit method. However, the exact details of its atmosphere remained a mystery until the James Webb Telescope came along, using its advanced technology. The James Webb Telescope was able to capture the light from WASP-39b as it passed in front of its star. By analyzing the spectrum of this light, scientists were able to identify the elements present in its atmosphere. They found that WASP-39b has an atmosphere of hydrogen sulfide, which is a sign of clouds in its sky. The discovery of clouds on WASP-39b is particularly exciting because it raises the possibility of liquid water existing on the planet. Water is essential for life as we know it, and the presence of clouds could indicate the potential for a liquid water ocean on the planet. However, further research is needed to confirm these findings and to determine whether or not liquid water actually exists on WASP-39b. Another remarkable discovery made by the James Webb Telescope is the observation of the atmosphere of WASP-39c. WASP-39c is another gas giant located in the same star system as WASP-39b. It is slightly larger than Jupiter and orbits its star every 11 days, similar to WASP-39b. The James Webb Telescope was able to capture the light from WASP-39c and analyze its spectrum. Scientists found that WASP-39c has an atmosphere of sodium, which is a sign of clear skies on the planet. The absence of clouds in its atmosphere suggests that WASP-39c could have a solid surface, making it a potential candidate for supporting life. Further observations are needed to study its surface and determine its habitability. Finally, the James Webb Telescope has also made an observation of the atmosphere of WASP-39d. WASP-39d is the smallest of the 3 planets in the system and is similar in size to Earth. It orbits its star every 20 days and is located in the habitable zone of the star. The habitable zone is the region around a star where conditions are just right for liquid water to exist on a planet's surface. The presence of liquid water is considered to be a key factor for the existence of life. The James Webb Telescope captured the light from WASP-39d and analyzed its spectrum. Scientists found that WASP-39d has an atmosphere of both hydrogen sulfide and sodium, indicating the presence of clouds in its sky. The presence of clouds on WASP-39d is an exciting discovery because it raises the possibility of liquid water existing on the planet. Further observations are needed to confirm this and to study the planet's surface and its potential for supporting life. The discovery of these exoplanets and their atmospheres is a testament to the power of human curiosity and our relentless pursuit of knowledge. It also highlights the importance of investing in scientific research and exploration. With the James Webb Telescope, we have opened up new frontiers in our understanding of the universe and the search for life beyond our planet. Who knows what other wonders and discoveries await us in the vast expanse of space? As we continue to explore the cosmos, we can be inspired by the incredible achievements of science and the endless possibilities that lie ahead.